So we're going to do some more tree diagram work, but this time an essential difference. Difference is that we're not replacing, okay? Not replaced. So let's have a little look, see what the difference is. So if you remember this one from last time, we worked through this one, but it was replaced at this point. This is called conditional probability. Everything else is essentially the same about it. So we got little pink ones here. So this is still the same at the beginning. That's going to be 5 over 7, and that's 2 over 7. But this is where it changes. So if we took a pink one out to begin with, what have I got left? If you look, if I were to take in one of those out, I've got 4 pinks left and 6 altogether. So now this probability here is 4 over 6, and probability of a green one would be 2 over 6. Remember what I said, don't try and cancel fractions down. Alright, this you'll see it a bit more clearer on this one about why you don't really want to do that, because obviously that's 2/3 and that's 1/3. You think, oh, let's write that down. Right, so what about if we took a green one out to start with? What have we got left? We've got 5 out of 6 for pink. So 5 over 6 and 1 out of 6 for green. Now everything else would be the same to do. Let's work out that the question about different colours. Okay, so let's imagine, so that happens there and it happens there. It doesn't happen there, it doesn't happen there. So let's go and just work these two out here. So if you remember how I did this last time, we did it like this. I was trying to summarise what you're doing as you're kind of going through, okay? Actually write down what you're working out. So otherwise you work stuff out and then you forget what on earth you've done. Right, so remember it's and, so this and this is 10 over 42. Okay, and the other root would also be 10 over 42. So if I now add this lot together, so the probability that there are different colour is equal to, so if I add those two together, 20 over 42. Now you can cancel it. Now cancel it. So if we cancel it now, that's going to be equal 10 over 21. Alright? Don't cancel it too soon. Right? If you cancel here, what would have happened is that you would have had this would have been 5 over 21, and this one would have been 10 over 42. Now it probably wouldn't have made too much difference with this particular one because it still is relatively easy to do. But if you leave the denominators alone, sort them out at the end, just ensures that all the denominators are the same, therefore you can add everything together much easier. Right, so let's have a quick look back to the question we did last time, and if you remember, this was the question that we did, and what it said was we had 5 red, 4 green, 2 white balls, and everything was replaced. Okay, and there was our solution there. Let's imagine this time that it's not replaced. Okay, so one ball is selected at random and then a second ball is selected at random. So what difference would it make? So I've got a little copy here for us. Alright, we're going to have a little look over here. So, and again, remember, just like pause it for a minute, okay? And try and work it out yourself first. So the first bit wouldn't make any difference. There we go. But if I've taken a red one out, that means I've only got 4 left and we've got 10 altogether. I would still have 4 greens and I would still have 2 whites. If I took a green one out, I would have 5 red. Remember there's only 10 altogether. I would have 3 green left and I would have 2 white. And you can always check these, look, because look, each little section should add up to 1. If I took a white one out to begin with, I would have 5 reds left, 4 greens, and 1 of those. Remember the other question? What's the probability of different colour? It would be these ones just here. Remember, you could work out the others and take it all away from 1 if you wanted to do it in a slightly different way. Let's quickly work these out. So I'm just going to multiply these together quickly, okay? So that gives me 20 over 110. That gives me 10 over 110. This gives me 20 over 110. This gives me 8 over 110. 10 over 110 and 8 over 110. Now, again, see, I could have cancelled some of these down. That was a half, that's 2 over 10, another half there, 1 over 10, 1 over 5, 2 over 5. Just leave it alone. Now, we add that lot together. 50, 60, 68, 76, 76 over 110, oops, 76 over 110. Now we could cancel it down, okay? And we can, if you just, both even numbers, so I could go 38 over 55. Just have a little check, maybe 3 doesn't, no, 3 doesn't go into it. 3 doesn't go into 38 to start off with. Doesn't go into 55 either, actually. Alright, so there's that one there. Right, do one more quick example, and again, same sort of idea, just pause things for a second, okay? Alright, so here's the last one. So, box of chocolates contains, what have we got? We've got 5 white chocolates, 10 milk chocolates. We've got Jessica and Ben randomly pick a chocolate. What's the probability that they select different chocolates? So, let's draw a quick diagram to represent what's going on. Like I said, some people with probability, they can just see exactly what to do straight away. Most of us, we find it a little bit trickier to do. So we kind of have to draw something just to help ourselves. So what do we got? So let's start off with Jessica. So Jessica, she's going to either pick, and again, look how I'm trying to spread these out. I'm trying to be really even about how I do this. So there's Jessica. Okay. I'm going to leave it as, I could write 1 over 2, I suppose. But I'm gonna write 10 over 20, 10 over 20, and that was, so white chocolate, milk chocolate. And then we've got, I'll just move that up a little bit, and then we've got Ben then selects one. So let's put Ben in. Kind of as you go through, the branches get a little bit narrower as we try and do it. Remember, try and keep everything nice and even as we go. Right, so Jessica hasn't had to worry about her probabilities, but for Ben, so he might get white, he might get milk chocolate, white, milk chocolate. Right, so if our white one's already gone, that means that there's only 9 left, and there's 19 chocolates left. No milk chocolates are gone. If the milk chocolate's gone, there are still 10 white chocolates left, and on milk chocolates there would only be 9 left. Alright, and now we can work out the question. What was the question? It was, what's the probability that they select different chocolates? So there we go. So the ones that we're interested in are these guys just here. So, and so Jessica, white chocolate, Ben, milk chocolate, and then it can be the other way around as well. So remember, that's 10 over 20 multiplied by 10 over 19, and then that's equal to 100 over 380. And then we could go around the other route as well, which is exactly the same calculation, which should be 100 over, whoops, put 360 then, 380. And probability of different colour would be that. Remember, sometimes it says something like, what's the probability that we get at least 1 milk chocolate? So therefore it would be these ones. Remember, you could turn it around and you could do one take away what it's not. right, if you want to try and be a little bit clever with doing that. Right, so we need to add these together. So if we add those together, remember, because the denominators are the same, we haven't tried to sort of cheat with that at all, then 200 over 380, and that's the probability of different colours. Oops, can't quite see that. Equals, and now cancel it down. Well, I can see that 10 goes into this straight away. So I can write 20 over 38. They're both even numbers. So 10 over 19. Okay. And there's nothing else that's going to go into those. Alright. So there you go. There it is. And so the probability that they get different colours is 10 over 19. So therefore, what's the probability that they get the same colour? Right, the same colour. So that would have to be 9 over 19. Alright? Right then. I think we can have a go at doing some questions now.